I'm building an Arduino-powered Hexapod from scratch, and for a long time now, I've been wanting to create attachments for it. They would allow you to customize the looks and functionality of your Hexapod by adding things like spikes, armor, cup holders, pretty much whatever you want. And with the help of the 3D printing sponsor of this video, AnkerMake and their M5 printer, I finally created them. But before I go over that, I had a more pressing issue to solve. The Hexapod was currently a paperweight. It needed the Arduino Mega and PCB, which I updated. There were two main changes. The first is that it's now 4 layers instead of 2, with an entire layer being dedicated to being ground. This made it so much easier to design. I was avoiding using 4 layers because I thought it would be more expensive, and technically it was, but it was only $20 more. The price substantially increases at 6 layers though, from $26 to $186. The second change is that I added a current sensor. Hopefully this will tell me if I'm pulling too many amps, and if I am, I can shut it down before any electronics get damaged. I ordered 2 fully assembled PCBs from this video's electronics sponsor, PCBWay. They've sponsored this channel before, but for 3D printing. I finally got to use them for PCBs, and I was really looking forward to how they turn out. Ordering the PCBs was simple enough, and if you aren't sure about something, that's okay. Their engineers make sure everything goes smoothly, and will contact you if something needs fixing. In my case, one of the resistors I used was out of stock, so they asked me for a different model. As far as I could tell, the PCBs were flawless. The installed parts had 0 issues. So the only thing I had to do was solder in the 2 terminal blocks, solder some wires together, and then plug it into the Arduino Mega. After everything was installed, the first test I did was hook up an LED to the 5-volt and ground outputs and hope it lights up. It did, so the next step was to hook up a leg, upload the code, and see if it moved. Because the new servos I'm using are 6.8 volts and my battery's voltage can be over 8 volts, I had to use a BEC, a battery eliminator circuit, to lower the voltage to below 7 volts. It sucks that I needed an additional piece of hardware, but these servos are almost 3 times cheaper than the ones I was using, so it would be worth it in my opinion. Alternatively, I could just use a battery that had a lower voltage. NIMH or nickel metal hydride batteries seem promising, but we'll see. Fortunately, the leg worked. I plugged in the rest of the legs, calibrated, and tested them. They worked, sort of, but things weren't moving properly. The issue was simple though. I just had the tibia and coxa wires swapped in 3 of the legs. Now it actually works. The cheaper servos and new design work insanely well. The BEC does get a little hot though. I'll move away from using it one way or another, but it's fine for the time being. Now it was finally time for attachments, and I had a ton of ideas. Spikes, armor, feet, cameras, ears, eyes, horns, weapons, roll cages, cup holders, kitten holders. Seriously, the possibilities are endless. If you have any ideas, let me know in the comments. I plan on making a second attachments video using solely viewers' ideas. In this video though, I'll be showcasing 3 attachments: leg spikes, leg armor, and a roll cage with a cup holder. To 3D print these attachments, I'll be using the AnkerMake M5 printer by AnkerMake, the 3D printing sponsor for this video. I've been exclusively using the M5 for this Hexapod project since the redesign, and it has been doing a phenomenal job. It prints really fast, has been extremely reliable, and it's been a pleasure to use. Check out the link in the description to learn more. I started with spikes. I wanted to start with something simple to minimize the amount of things that could go wrong. The idea was this: spikes that attach to the servo mount on the tibia. Simple. Designing it was straightforward. 3 curved spikes attached to a flat plate with pegs on the bottom that slid into the ventilation holes on the servo mount. After I was happy with the concept art, I moved on to modeling. The tricky part was making it 3D printable without supports. Because the current design had protrusions on the top, the spikes, and the bottom, the pegs, I'd have to split it up into multiple pieces. The question was, where should I split it up? The answer is pretty obvious. Split it at the base of the pegs. I was now faced with a choice: use screws and heated inserts to attach the pegs, or try to create a locking mechanism for the pegs so that once they were snapped into place, they couldn't be pulled out again. Naturally, I chose the snapping mechanism route, since it would reduce the amount of hardware needed, and how difficult would it really be to design something like that? Very. After 10 iterations, I gave up. To be fair, the 10th version worked pretty well, but not as well as I wanted it to. I realized that if it took me this long to get the fit right, others would have issues as well, so I just moved on and figured I'd fix it later. Here's what it ended up looking like. It came out pretty much exactly how I envisioned it. For the leg armor, I wanted it to curve with the tibia and wrap around the side. When designing it, I wasn't thinking about 3D printability at all. I just wanted it to look cool. It took a while, but I was pretty happy with how the concept art turned out. Not gonna lie though, I was not looking forward to trying to model this. It's a relatively organic shape, and part of me really just wanted to go back to Blender, but I'm very glad I didn't. The trick was to use sweep. Sweeping is basically extruding along a path. I started with creating a curved rectangle that loosely matched the side profile of the tibia. Then I created a path I wanted to sweep along, then I swept. With roughly the shape I wanted, the rest was smooth sailing. I filleted both corners to get the curves I wanted, added some chamfers, tweaked it a ton, and I was done. For the base, I started with the spike base and replaced the spikes with some little arms to hold the armor plates in place. I made holes in the plates that the arms fit into. I figured friction would be enough, and I didn't want to use heated inserts and screws if I didn't have to. When I went to 3D print it, I was pleasantly surprised to find that there was a perfectly flat side that I could place on the build plate. And even better, no supports were needed. In hindsight, splitting the armor straight down the middle would indeed cause there to be a flat side, but I didn't do it for printability. I did it for looks, so the fact that it helped both was nice. Printing and assembling went smoothly, but there was an issue. Because I was using friction to attach the armor plates to the base, it was too easy for them to come loose. The armor plates should be rock solid. You shouldn't ever be worried it's going to fall off, and there was only one way to ensure that it wouldn't. Heated inserts and screws. But like, who could have known I would have had this issue? Except, me. I removed the two middle arms, made the remaining four thicker, added heated insert holes to them, and added screw holes to the plates. This solution is a lot better. The plates don't budge at all. I also applied the same solution to the pegs. This was technically version 11 for the pegs, but it was my first attempt at the heated inserts and screws method. And it worked. First try. I have considered screwing directly into the 3D print without using heated inserts, but I'm worried that the hole will get stripped and I'll have to throw the entire part out. Now, if I'm completely off base, let me know. These aren't meant to be unscrewed, so heated inserts may be overkill. Here's how the leg armor turned out. I am super happy with how it looks. It's got a portal aesthetic going on that I absolutely love. During my streams where I was recreating the Hexapod in Fusion 360, I actually tried to make a roll cage, but I failed miserably. Not ideal, but we're getting there, I think. He did not get there. This time around, I went for simple. Nothing flashy, nothing asymmetrical, just a design that made sense. Easier said than done, though. I also wanted to throw a cup holder on top to take some pressure off of making the design look cool, since the main focus would be the cup holder. Even though it looked simple, modeling it was deceptively difficult. What ended up finally working was creating a single corner leg and half of a middle leg, and then mirroring them across both axes. With the cup holder, I just wanted something that could hold a normal can of soda. The design I came up with was pretty cool. Instead of just a hollow, topless, boring cylinder, I went with 6 arms that go up and around the can. The idea was for the arms to grab onto it. Originally, I wanted it to be able to hold an entire 6-pack, but they wouldn't fit without colliding with the legs. Even if it did fit though, I doubt the entire Hexapod would be able to support the weight of 6 12-ounce cans. I was able to fit 2 though, so that's what I went with. I started with printing a single cup holder, a cup holder mount, and the tip of one of the roll cage legs. This was to make sure the leg fit properly in the frame and that my magnets would fit into the hole under the leg. I didn't want to print the entire roll cage until I knew everything was sized correctly. The cup holder mount and roll cage test were perfect. The cup holder was not. The can fit, but not snugly. I wanted it to constantly be pressing against the can, so I redesigned it to do just that. I made the 6 arms taller and curve inwards. I also made the base of the cup holder a bit wider. These changes worked. It now gripped the can exactly how I wanted it to. Next, I printed the full roll cage, which proved to be quite annoying. In theory, printing it upside down was ideal because you'd only need support on the tips of the legs, and I could redesign it to not even need that. This worked, but the finish on the top of the legs looked awful because of the overhang. And this was an issue since it's the most visible part of the roll cage. So naturally, I tried printing it right side up with a ton of supports. I really didn't want to show this, but it failed because the legs detached from the print bed before it could connect to the supports. I noticed right away when it happened, so I tried reattaching with duct tape, and that went about as well as you'd expect. It was painfully obvious that I needed a brim, and I should have had one from the start, especially with a 5-hour-long print. The brim worked! There were some issues, but it was good enough for now. The cup holders could hold the cans, but what wasn't clear was if the Hexapod could walk properly with the added weight. There's only one way to find out. I printed a second improved cup holder, attached everything, and started it up. It worked with no sodas, no problem. It'd be worrying if it didn't. One soda worked. 2 sodas worked. I still have no idea if 6 sodas work, but I can test that at a different time. The magnets holding the roll cage on seemed like a good idea at the time, until you attach 2 full sodas to the top and start jolting it back and forth. It's fine though. I needed to reprint it anyway. I want to make it a bit taller so there's more room for the electronics, so I'll replace the magnet holes with screw holes. But anyway, if you need your soda shaken and delivered, I have just the robot for the job. I am so happy with how these attachments came out, especially with how the leg armor looks. I may try to design a roll cage with a similar aesthetic. Also, the cheaper servos brought down the cost substantially, which is exciting since it'll open up the project to so many more people. Thanks again to PCBWay for sponsoring the electronics and AnkerMake for sponsoring the 3D printing. In the next video, I want to do even more attachments, but this time designed by you guys. If you have any ideas at all, let me know in the comments, and if they're good, I might just make them and feature them in the next video. If you want to have a really good chance of being featured, design them yourself. Use the STLs linked in the description as a reference and send the designs as either an STL or a Fusion 360 file to the email linked in the About section on this YouTube channel. I am really looking forward to what you guys come up with. This is the first time I'm asking for direct help with this project, so it should be interesting. I hope you enjoyed the video. I'll see you and hopefully your designs in the next one.